sight, which is vision, sound, which we hear from our ear system, and we generate through our vocal system. Third is smell. Fourth is taste, and fifth is touch. So these are the five senses God has given us, and almost all senses, they are inspired from these five senses. There are various sensors available in technology that I'll be discussing in the PPTs. So these five senses has been integrated in different sort of applications, like sonar is one of the wonderful applications. Radar, you are already aware of. We make use of electromagnetic waves in radars. Then now present technology is LIDAR, which is coming up, and there are many more. But how to develop these sensors inspired through five human senses will be today's talk. Then I'll be giving you a case study of piezoelectric effect converted into sensors, and then we'll try to develop ultrasonic sensors which will be used for a particular application. I've used for wildlife control, that I'll be explaining as a case study. So I'll just share my screen. This already spelled out by Richa Gupta. Now, CS told that there are two books. This is my third book, which is last week inaugurated by Deputy CM, and this is based on terahertz DRA sensing. It is published in IIT London. Last week we have inaugurated, and the title of this is Terahertz DRA for Sensing. It is available in hard copy. Anyone who wishes to have, they can procure for the library. Now, as the title given to me is design and implementation of sensors. So these sensors I'll be talking about either based on sounds or electromagnetic waves. So I've classified all sorts of sensors in two bifurcations. One is sound-based sensors and another is electromagnetic wave-based sensors. Now, this is the definition of sensors. A sensor is a device that produces an output signal for the purpose of sensing of a physical phenomena everyone is aware of. We use in our healthcare a lot of sensors which are based on physical phenomena. Then an electronic sensor, I'll be talking today more about electronic sensors and we'll try to develop them. Electric sensor is a device that detects a physical parameter of interest, either it may be heat, light, sound, and then converts into electrical signals that can be measured by instrumentation and used by electrical or electronic systems. So this is all about sensors. Now, in our day-to-day life, we come across, but specifically, I have chosen few case studies so that we can use these sensors for the application of the society. I'll be talking more about this wildlife control system. We are working on this using ultrasonic sound waves. So when I say wildlife control, we should know the biological characteristics of wildlife, and then based on those biological characteristics, we must be able to develop ultrasonic systems, because in nature, the hearing capability of human is in audio system, and the wildlife animals, they are having the frequency spectrum right from audio frequency to ultrasonic. So ultrasonic, these sensors are more useful as far as wildlife is concerned. Then in US already they are using these sensors for crowd control. There are Fitbit and all electronic devices they have developed, like insects, mosquito, and other. But they have already studied physiological characteristics of or biological characteristics of those wildlife. We see in our day-to-day life for crop monitoring, monkey, mosquito, insects, lizard, they can be controlled using these sensors. As I said, most of the wildlife, they are having capability to hear audio waves, audio sound waves, as well as ultrasound waves. Then water or ocean monitoring. This is one of the wonderful area. Especially the ocean is there. We can use ocean sensors to monitor not only ocean life, but these water life of the creatures. And their sonar instrumentation will play a critical role. So I'll be talking about sonar too. Sea, ocean temperature, and these are not only measured physically, but nowadays making use of satellite. These sensors are integrated with remote sensing, and sitting at Delhi itself, you will be able to characterize the ocean characteristics, maybe at Chennai, maybe at Andaman. So, because of development of the technology and sensors. With the help of sensors, you can see or monitor ocean temperature, salinity, density, tide, tsunami, etc. And these are possible with the help of remote sensing. The oceanography and then Ministry of Earth Science, they are heavily investing in these characteristics to study and give it to naval research and development centers. Then comes to environmental sensors. You come across such as gas sensors, temperature sensors, humidity sensor, air pollution sensors, water milk adulteration sensors, and many health parameters you are already aware of, like oxygen, glucose, blood, ECG, pulse, then heart rate, etc. A lot of sensors are available in the market. And if you go one step ahead, making regression analysis, you can even predict all these parameters if you have integrated sensors with mathematical or computational capability, making use of artificial intelligence and machine learning. You will be able to get the last parameter, which I have indicated here, as predictions of all these parameters. It's possible. But especially Australia is doing wonderful work as far as prediction is concerned. They have developed the health monitoring system. They register every parameter of individual, and a unique ID is being given. And based on those unique ID, these sensors are integrated to generate database. And based on those database, they are able to get predictions about health of the individual. So this is wonderful task the Australia is doing. In my today's talk, the discussion main points are ultrasonic sensors, electromagnetic wave sensors. I'll be, if you are interested, talking about radars, LIDARs, infrared sensors, sonar, piezoelectric effect, and Helmholtz equation, because the ultrasonic sensors are based on Helmholtz equation and Rayleigh equation. Then comes to PZT. These are nothing but piezoelectric based materials, lead, zirconate, titanate. There are various other materials which are being used like ferromagnetic materials to develop these sensors. Then I'll be taking one case study, ultrasonic speakers, to design and develop ultrasonic speakers. These ultrasonic speakers are different from the public addressing system speakers we'll come across. You can raise questions, what is this ultrasonic speakers and how it is being developed, what is the difference between the PA system speakers and ultrasonic speakers. Because these are useful for ventilators, control and rescue operations. Then comes to sensor applications for the society. I'll integrate these ultrasonic speakers with sensor and applications for the use of society. Then, as I already said, satellite and remote sensing. These are being used in oceanography and in specific the navigational part of your naval ship, submarine, etc. For these, as I already said, that I have classified the sensors in my present talk in two broad categories. One is sound-based sensors, and another is electromagnetic waves-based sensors. So all wireless sensors, they are electromagnetic wave-based, but the ultrasonic wave-based can also be a wireless sensor. You will see the difference. Now, these sensors, it means these sensors basically require two broad categories. One is generation of sound waves and reception of sound waves. Second, generation of electromagnetic waves and receiver of electromagnetic waves. Then only your sensors will be complete as far as electronic system is concerned. Now, nature has given us a beautiful sound wave generator system. You can see our vocal cord. In our vocal cord, we are able to generate fine modes, and these modes are nothing but field patterns. And field patterns which are being formed by sound waves, I classify these as ferments. It means in generation of sound formats, I need a mechanism, and this mechanism will be classified in terms of formats being formed by sound waves or pressure waves or mechanical waves, which are longitudinal in nature, and I name them as ferments as far as sound modes are concerned. We'll see in detail. For example, if I utter A, B, C, it means I'm able to generate different format of the mechanical waves or the air particles compression, or these are we call them longitudinal waves. So air particles will form certain patterns. We disturb them because of pressure or force we apply. Certain format is being formed. Those are waves. So wave formats are being developed. These wave formats will be based on frequency and the pitch or magnitude. But these formats we must be able to reproduce. So we have human has ears to recognize what formats has been developed by using our vocal system. How it is being developed, I'll tell you the mechanism. Basically, we have lungs, so air comes from the lungs. Then we have vocal cord, which vibrate at particular frequency. Then we have a cavity of our mouth. We have tongue movement, lip movement. They will be forming these formats. So if we code these formats based on A, B, Z, different format will be there. And to decode that, God has given us ear. That is beautiful mechanism. How this is being decoded? As you already know, that sensors are nothing but one sort of transducers, or you can say synonyms. or you can say the sensor may be a sub part of transducer. Basically, they convert one sort of signals into another sort of signal. Maybe here, when we talk about the ear, they receive air pressure or formats or sound waves of different formats, get into our ear canal. Then in ear canal, we have in median a hammer. Based on that pressure or format, that hammer will hit a some sort of liquid is being filled, that is known as cochlea in ear. So these pressure wave or mechanical waves gets converted into water fluid waves in our cochlea. Beautiful mechanism is there, and there are some fine hairs of different length. That length will vibrate and some sort of ionization will take place. And that ionization will be specific to the frequency, pitch and the frequency. So these mechanical waves are getting converted into electrical signal in cochlea, and that electrical signal will travel to our brain through sensory nerves, and then that will be recognized. So sound waves are being again require our brain to process. So this is one how your ear, how your vocal system, they are sync, they are in sync. If there is no sync, we will not be able to recognize what voice is being produced. Similar is the scenario as I classified five senses. One is sight, vision, another was sound. Sound system I have explained, it is being developed based on ear and vocal system. Then sight. Sight is nothing but vision. This is also beautiful sensor. Out, we have photons. These photon enter into our retina through this lens and the outer part of the eye. And in our retinal part, we have conical and cylindrical rods. These conical and cylindrical rods are hit by photons, and they are somewhere 130 million cells are there, which are cylindrical in nature. We call them rods. They are cylindrical in shape. They are 10 layers, and these 10 layers are of different material. When photon hit being incident on this cylindrical cell, it converts these fine 10 layers of different pigment into electrical impulse. So you may raise questions how you are able to convert these photons into electrical impulses. As I said, 130 million cells are there. In 130 million, somewhere 125 millions are rods and 5 millions are cones. Cones and rods are nothing because these are shaped in cylindrical or conical shape. That is why we call cones and rods. So these rods are responsible for black and white vision. Whereas conical shape, again 10 layer material of different pigment, they are in conical nature. They operate at visible frequency. The visible frequencies somewhere 350 to 430 to 750 terahertz. This is visible range because our eye operates at visible range. So these conical are of somewhere three different wavelengths of 5 micron, approximately 5 microns. So they are responsible for RBG color capturing. If your color vision is not working, it means there is some problem in the pigment area of your conical cells. If your black and white vision is not fine, it means there is some problem in your rods. 125 million rods and 5 million cones are there. So they are able to convert each photon into one neuron. So 135 neurons you received with the help of processing of the pigment of cylindrical cells, and 5 million neurons you could get convert your photons by making use of these 5 million uh, conical conical cells. Total 130 millions. It means there is a bundle of wire sort. These are known as optical nerves. Bundle of optical nerves which carry these neurons to your brain, and then brain develop the image. That is how we see. This is sight or vision system is being formed. Similarly, I have not developed smell, tough, and smell, touch, and taste, but similar sort of this. It means the input signal is being converted into electrical impulse. Let it be smell, let it be touch, let it be taste. So two mechanisms I have explained. One is sound, another is
Excuse me, sir.
sight.
Sir, sorry
Yeah.
for the interruption. Sir, I think
Pardon me?
the slides, sir, the slides are same.
I have not
Yes.
changed. The slide discussion point I have kept same. I'll change when I'll tell you.
Okay, okay, sir.
Okay, now I think it is getting changed. See.
Yes, sir. Yes, sir.
Okay, okay. So now when I talked about these sensors, this is a frequency spectrum. Now you can see the sounds with a 20 kilohertz and higher has been placed in ultrasound spectrum. You can see here our audio system formed 20 kilohertz. Below 20 kilohertz is our audio system, and after 20 kilohertz to around 20 megahertz, this is ultrasound. So we make use of this ultrasound system and develop sensors. Now here, the beauty of this particle spectrum, you will observe that the human, if you develop your sensors beyond 20 kilohertz, somewhere in this green range, you will have the great advantage of that whatever you are doing is being not heard by human. So making use of this particular advantage, you can develop wildlife control. We'll see how we can do so. So I wish to play in this region beyond 20 kilohertz to 200 megahertz, because there is no disturbance to the human life if you develop sensors in this particular domain. Now, the second part is this electromagnetic or radio waves. Now here, if you see this 10 raised to power 10 hertz, this is microwave region, it is fully occupied. This band is fully occupied and not available, very congested. So I used to play in this domain again. You see the terahertz there, 10 raised to power 12. If you develop your sensors in this particular domain, it is freely available. So more research is going to develop these sensors in this domain. Infrared, of course, people are lot of people are working in to develop infrared sensors, especially camera, etc. These are in infrared domain. Then visible light. This is being used by human being, and then comes to ultraviolet, X-rays, gamma rays, of no use as far as communication is concerned. Now here, you can stop me anytime. You can raise questions. There's no hitch as far as question is concerned. So now sound and electromagnetic wave generation and reception. These are the two mechanisms to develop any of the sensors. I have explained your vocal system. I have explained the earphones or ear system. I am going to explain you the antenna system, which will serve the purpose of generation of electromagnetic waves and reception of electromagnetic waves. Now, if you see how to generate electromagnetic waves, again, as I said in vocal system, vocal cords, we develop a particular format of fields, specifically sound waves. So specific format is being developed. We will see how that same format is being developed by radio waves or electromagnetic waves. If you see here, these electromagnetic waves are generated by rapid oscillation of electrons. I'll tell you the mechanism also. These RF waves bounce back and forth between resonator walls, thus forming standing waves. So, standing wave will not serve our purpose. We need traveling wave. So, these standing waves are only used for storing electrical energy. Oscillating current introduced oscillating magnetic field, that is as per law of conservation. Time varying field now becomes second order differential equation. This is of our interest. Solution of second order differential equation is sine wave or cosine. We take basis function of this. If I'm going more detail, you can stop me. So based on this basis function, it radiates away from antenna into space due to accelerating or fringing currents. But to convert this standing wave into traveling wave, we require boundary conditions. And these boundary conditions are being solved based on Helmholtz equations or one is Helmholtz equation, then modified characteristic equation is also there, where we have taken 6 different cases, and based on those different cases, we have modeled how to convert these traveling standing waves into traveling wave, and we could find that it is in our control, where from we have to in which side we want to convert this standing wave into traveling wave, and that is why they develop the pattern or radiation pattern. But the researchers have already investigated that with the help of simulations or mathematical work, you will be able to predict what type of modes you are generate, and depending on the type of mode which you are generating, you will be able to control your radiation patterns. So thus the power is radiating to space in a particular format. This is the device. Whatever I have written here is being depicted with the help of sketch. I have taken rectangular case. We can take cylindrical, spherical, or any arbitrary shape. And based on that particular shape, we will be applying these electromagnetic generation mechanism. And then where from we have to create this far field point, either from this wall, from I can create these from this wall, any of the walls. This in design control. So the theory of this design control is being spelled out here. The resonant modes, excitation and control. Again, the generation of resonant modes depend on aspect ratio. Here, if you see this particular diagram have dimensions. So from these dimensions, D, B, and A also, I think he has not written W. In place of he has written W, epsilon R, theta, Z. So depending on those, we classify these parameters. Generation of resonant modes depend on aspect ratio, feed point, structure. Higher order fundamental modes can be generated at the same time. Using cavity to create airspace by removing dielectric material can be used to suppress any particular higher order resonant modes. Aspect ratio and structure can be used to control beam width. Air gap and stacking, these are all being implemented in this particular structure, whatever I am reading here. The flexible substrate such as RT Durod, RT, these are Roger materials, can be developed to can be used to develop conformal designs. Then there is a beautiful mechanism. Merging of modes can be done in these structures. Height can be used to excite. We can play with height for carrying out sensitivity analysis and develop higher order modes. Hybrid modes can be excited in this structure even odd modes can be excited in this structure. Basically, we already have studied in our EMFT, the modes are nothing but field formats. And these field formats are termed as T, TM, and TEM. In antenna theory, we tried to generate physically these T, TM, and TEM formats, and these are known as resonant modes. As in our vocal system, when we say A, it means one format is there, B, second format is there, Z, some third format is there. In similar way, in EM theory also, we develop modes when we transmit any of the signal from our antenna. So antenna is beautiful sensor. It is transmitter as well as receiver. Same sensors make use of reciprocity theorem, and you need not to do anything. It will have similar characteristics in trans as well as in receive. More than height, hybrid modes can be excited. Higher permittivity DRA or metal strips can modify the modes. We can make use of these merging and other characteristics to shrink the size of the device. Polymer DRA for conformal antenna can be used. We can generate multi-band, wideband, and many other characteristics. Current density is altered if any specific region. Thus, more you just listen this current density word, because the same current density word we will be using in piezoelectric effect when we develop ultrasonic sensors. BST can be used to design active antennas. This BST is barium strontium titanate, this material. So how these resonant modes look like is being depicted by this figure. Recently, I was watching this Shark Tank. Some serial is coming in TV. So they have developed a scanner or sensor which can tell you how this apple looks like from the inside. But they have not used electromagnetic waves, they have used infrared waves. So how here this particular theory will be able to tell you how you are able to visualize the scanning or the mechanism which will be able to show you inner part of the apple. And these are nothing but dipoles. What we do, if you see here, short magnetic dipoles, this is TE delta 111, TE delta 13, TE delta 15. If you decode these are the pictures. One short magnetic dipoles. So dipole, we are basically in apple at molecular level with the help of infrared, which is input excitation. We are playing with dipoles of apple molecules, and we create misalignment in two dipoles. So dipole movements are being created, and those dipole movements are being studied with reflected energy, which we gave as incident energy, and then we will be by decoding those dipole movements, we will to narrate that which is what is dielectric constant of this particular apple, and then based on that, we will be able to visualize that whether it's healthy, unhealthy, or what shape of your apple is there inside. So this is basic phenomena which is being used in that device. So here, this is TE delta 111. This is, I'll say, if I say X and Y dimensions, number of half-wave variations are being represented Y and Z process. So I call it TE111. There are one-time variation in Y direction as well as in Z direction. So this is fundamental mode. Now, if you see second figure here on top, TE delta 13. Here, along W means x-axis. Here I have taken Y. I can say Y or X, whatever it is, and on top it is Z. So here it becomes Y versus Z. TE delta 13. So 3 indicates Z, 1 indicates Y, and delta means which is not being depicted. So this particular 2D figure indicates Y and Z. So in Y dimension only half a variations one time, whereas in Z direction 1, 2, 3. In third figure, CE delta 15, there are 5 variations across Z. So that is why this is created by input excitations and structure of this device. It is in the control of designer. So based on this, these all whatever I have read, these all phenomena can be created, and the application of this can be either we can study multi-band, we can study single band, we can merge, develop wide band. So different applications are there. Now this is a theoretical study. These diagrams have been obtained by simulations, but you can yourself study those whatever has been observed by simulations with hardware development and practical instrumentation. This is one example. Now, this particular phenomena of generation of resonant modes can be either on ultrasonic levels, or it can be on microwave levels, or it can be higher, maybe at visible frequency, maybe at infrared frequency, maybe at millimetric wave. So depending on the use of frequency, sometimes physics will also change. A device designed for ultrasonic wave will have different material characteristics. A device designed at millimetric wave will have different material characteristics. A device designed at terahertz will have different characteristics. I'll give an example. For example, there is a copper metal. If I incident electromagnetic waves or microwave wave on that copper metal, it will reflect that input signal. But if same signal is at terahertz, higher terahertz, it will not reflect, but it will get into it. It will penetrate through that copper wire. So this is nothing but frequency characteristics at that particular material. So the physics of materials and physics of electromagnetic waves is different as far as spectrum is concerned. We have to keep that thing into mind. If you are developing a ultrasonic sensors, different physics you need to apply. If you are developing a visible range sensor, the physics will be different. If you are operating millimetric wave sensors or microwave sensor, the physics will be different. So accordingly, you need to integrate. I think this retinal quantum antenna, we are working, one of the students is working here, and they are able to develop artificial retina for restoring human sight. So I've already explained these rods and cones can be developed artificially, making use of these material which are compatible with the human body. These are known as retinal prosthesis. Now, broadly as a layman, the type of sensors can be written: temperature sensor, pressure sensor, touch sensor, image sensor, motion sensor, light sensor, vibration sensor, humidity sensor,